Welcome to another deep dive. Today we're tackling a really interesting bit of NLP, Doc2Vec.
That's right. Document to vector.
Yeah, and our source is this great excerpt explaining how it lets computers, get a grasp on whole documents.
Exactly. It's a step beyond just single words, like with Word2Vec. We're talking about representing maybe a sentence, a paragraph, or even a whole document.
As a single vector, like a set of numbers.
A single fixed-length numerical vector, yeah.
So the idea is we take these documents, turn them into points somewhere in like a high-dimensional space.
And the key is that similar documents should end up close to each other in that space.
Okay, so our mission for this deep dive is basically, what is Doc2Vec? Why is having that numerical version so useful for you listening? And how does it actually work according to the source?
You got it. It's all about mapping the meaning, the semantics of a document into this space where, distance tells you about similarity.
Sometimes called paragraph vector too,
Yeah,
right?
right. Paragraph vector is another name you'll hear. It's pretty popular in NLP because it lets you do things that just matching keywords can't really achieve.
Okay, let's get into that. What kind of things? Why should you care about having a document as a vector?
Well, think about it. Once they're vectors, you can actually do math on them.
Right.
So the source points to applications like comparing documents much more robustly, or classifying them, clustering them.
Similarity analysis too.
Yeah, exactly. So instead of just finding documents with the same words, you can find documents that are about the same topic, maybe even have a similar tone, even if they use totally different words.
Ah, okay. That lets you organize huge amounts of text in a way that makes sense conceptually.
Precisely. It gets closer to how we might sort things based on what they're actually about.
And the source says this is usually done with neural networks, unsupervised learning.
That's the typical approach, yes. It learns this unique vector for each document. The source sort of describes it as capturing the essence or the topic of the document within that vector.
And it learns this just by looking at the documents themselves.
During the training process, yeah. It learns the document vectors as it trains the network on the text data.
Okay. Now the source mentions two main ways, two flavors maybe. Distributed memory, DM, and distributed bag of words, DBOW.
Two main architectures.
Let's unpack those. What's the story with distributed memory, the DM one?
Okay, so DM is often seen as like a direct extension of Word2Vec.
Yeah.
It learns the vector for a chunk of text, could be a sentence, paragraph, whatever, by using its identity when predicting words inside it.
Using its identity. How does that work?
Well, the model is trying to predict a word in the middle of a sequence, right?
Right.
Its input isn't just the words around it, the context words. It also gets a unique vector representing the whole document that word came from.
So the document vector itself is an input.
Exactly. It acts like another piece of information along with the word vectors. And the network learns both the word vectors and those document vectors at the same time.
As it tries to predict the words accurately.
Yep. And the source suggests that because it uses this context and the document's overall identity, it's pretty powerful for capturing meaning.
Okay, that makes sense.
Yeah.
DM uses the document ID plus the surrounding words, learns word, and document vectors together.
Got it.
What about DBOW? Distributed bag of words? Sounds simpler.
It is, structurally. With DBOW, you're primarily learning unique vectors just for the documents. You don't really involve separate word vectors in the main prediction task.
Wait, so if it's not using word vectors or context, what's it predicting from the document vector?
It takes only the document vector as input,
Okay.
and then it learns to predict a randomly chosen word from that document.
So it's like trying to guess which words belong in the document, given only its vector.
Exactly. It treats the document like a bag of words. The order doesn't matter at all.
Like just a collection of words.
Precisely. That makes the network simpler, and the source notes it's usually faster to train than DM.
But the trade-off is...
Well, by ignoring word order, it might miss nuances that depend on sequence. Things like negation or subtle meaning shifts might be harder to capture.
Okay, so that clarifies the main difference from the source. DM looks at context and order, uses both word and doc vectors, probably better for deep meaning. DBOW ignores order, just uses doc vectors, faster but maybe less nuanced.
That's the core trade-off, yeah.
Right. So wrapping this up from our deep dive into the source, Doc2Vec is this powerful technique for turning documents into numbers, into vectors, which lets us move beyond just keyword searching and start doing analysis based on semantic meaning, comparing classifying clustering.
And you have these different flavors, like DM and DBOW, offering different balances.
One more context-aware, the other faster and focused on just the words present.
Exactly. And maybe a final thought for you to consider, connecting this back. Thinking of documents as these points in space really changes what you can do with text data.
Yeah, it opens up possibilities.
So think about this. Based on how they work, for what kinds of practical text analysis tasks would DM's focus on sequence and context be really critical? And where might DBOW speed and focus on just the vocabulary be good enough? Or maybe even better?